we have question 5. Zach is in training for an athletics competition. He runs a distance of 200 meters measured to the nearest 10 meters. So 200 meters to the nearest 10 meters. His time is 35 seconds measured to the nearest 5 seconds. Okay, 35 seconds to 5 seconds. Find the upper and lower bounds of his speed. Now, as soon as I've given it some upper and lower bounds at all, I'm going to write 200 meters to, well, nearest 10 meters. So that's 10 meters there. Look at the number next door and go 5 above and 5 below. So that would be upper bound first, 205, 205. Lower bound, 195. Makes sense. This is the difficult one, to the nearest 5 seconds. You can't go 5 above and 5 below. You actually do half of that. And you go 2.5 above and 2.5 below. So we do lower bound 32.5 and upper bound 37.5. Okay, that's getting me method marks. Now, work out the speed. Now you should know the formula speed equals distance over time. And I want the minimum speed, the lower bound, and it's a fraction. So I want the fraction to be as small as possible. So following the pattern from before, smallest fraction means smallest numerator. So distance needs to be 195. And I want to divide by the biggest possible denominator, 37.5. Type that into my calculator, 195 divided by 37.5 gives you 5.2. That's the minimum speed in meters per second. Maximum speed, or upper bound, this would be the biggest denominator, biggest numerator, biggest distance over quickest time, lowest time, 32.5. Type that in, 205 divided by 32.5, which is not the nicest number, so I'm going to round this to 3SF, 6.31 meters per second to 3 significant figures. Okay, question 6. You've been given a semicircle and it's measured 50 meters squared. So you've got semicircle, center, radius, 50 meters squared to the nearest 5 meters squared. Again, one of those awkward ones. Find the upper and lower bounds for the perimeter. Okay, this is really difficult. Okay, right, let's try and do this. So, perimeter is around the outside. So P for perimeter. Let's come up with a formula for perimeter that gets me a method mark guaranteed. Now, obviously you've got two radiuses, so R plus R. But you've got the curved part, which is half the circumference. So if the entire circumference is 2 pi r, you want half of that, so you just add in pi r. So that bit there is a half of 2 pi r. Okay. And what I want to do is just substitute radiuses in right now, but I haven't got the radius, I've got the area for some reason. So before I can do anything, the area formula is pi r squared. And you've got two different options for the area. So the area could either be split it up to the nearest 5 meters squared. So you can't go 5 above, 5 below. You go 2.5 above and 2.5 below. So 52.5 and 47.5. And those are the possible values for the area. And then that value will give you a radius, and that value will give you a different radius, and they will be the upper and lower bounds for the radiuses. So let's try that. Make r the subject in this formula. How can you make r the subject? Okay, well, r's been squared, then times by pi. So work backwards. Divide by pi. Got to write fractions in algebra. Square root. R is equal to the square root of the area divided by pi. Let's try this area. R is equal to the square root of 47.5 divided by pi. What does that give me? 47.5, no, square root of fraction 47.5 over pi. 3.8884. I'm going to leave that as it is for now. The other radius is square root of 52.5 over pi. Change this to 52.5 to get 4.08794 ... Okay, so you had two different areas, minimum, maximum, to produce two different radiuses, minimum, maximum, and then you want to work out the minimum and maximum of the perimeter. So minimum perimeter is radius plus pi times the radius. So you want that to be as small as possible, so you pick the smallest radius. So it'd be, let's do this to 3SF, so 3.89 plus 3.89 plus pi times 3.89, which is equal to something. So 3.89 plus 3.89 plus pi times 3.89. Okay, let's go with 20.0. Perimeter would be measured, in this case, in meters. And then max perimeter, you want this formula to be as big as possible. So you pick the biggest radius possible. So 4.09 plus 4.09 plus pi times 4.09 equals 4.09 plus 4.09 plus pi times 4.09 to give you 21.0 meters to 3SF. Okay, up until that last question, things were pretty standard, but then that was really difficult. Okay, so any questions about any of this? Add opposed to teams.